Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today we're going to talk about swapping in a rigid body buoy model into a mooring design. Previously, we'd used ProteusDS Oceanographic to set up a floating LiDAR buoy, which is a very large self-stable buoy on a mooring in 1,000 meters water depth. There's a mid-water float to give some pre-tension to the line. It's a little bit down from the surface, but then this tether portion is very low tension to the buoy. Well, what the problem here is that with a point model for the buoy, where we don't model any of the dynamics of the orientation, and instead the orientation is taken from the tilt line of the angle. When there's lots of low tension in the mooring, you get a lot of tilt. It's not really realistically representative, especially for self-stable buoy. So we need to replace this with a 6 degree of freedom rigid body model. So the first thing we're going to do is we completed the static analysis. We're going to convert it to a dynamic model and then swap out the point model for the float with a rigid body. Let's go back to our static model of the mooring. So when we use export, the final state, it's going to use that as a starting point for a new project. We're going to call this dynamic. The first thing we need to do is convert the quasi-static model to a dynamic cable model. So we'll go to configuration, convert dObject, quasi-static to cable, and the only one you can convert is this one, so we'll go and complete that. So now when we look at the visualizer here, you can see we've got the deflected state of the mooring as the starting point, and what we're going to do is turn off the we're going to turn off the point buoy model at the top. That's this XMS cylinder here. And you can either delete the line or just insert a comment there and you'll see it's disappeared from the top. Now, we will need to add in the rigid body. Previously, we'd set up a rigid body model of the buoy. We can see the information in this other Proteus simulation toolbox project. Now, for the moment, the best way to copy this is just going to be copying the contents from one project to the other directly. So we'll create a new rigid body. We can just call it buoy. And we'll go to our rigid body buoy here. We'll copy. It does not automatically copy the features. So if we go to feature definition in our new project, it'll say, oh, it needs to create it. And again, we can go to the feature definition by right-clicking, and you'll see in the library here we've got our cylinder hull. Again, I can select all by Control-A and Control-C, copy that. And I'm just going to do exactly the opposite. I'm going to delete everything in here and paste it all over in there. Perfect. Now, the only thing is they're not lined up with each other. So I've got the buoy selected here. If I click on this target icon, well, the initial state's way off over here. How do we get them to be lined up the way we want? Well, you can read off the boundary state of the cable here and then move the state over. So if we click on state, you'll see I know that this is the node 0 position. So there's a little bit in Z, but really almost nothing. And then really it's this X position that I want to get. So it's 183.4. So let's move the rigid body over 183.4, and maybe we'll just leave that for now and then see what happens. So I've got my rigid body selected here, and click on the target, and it's very close to where we need it to be. Maybe I would even move that buoy up just a tiny bit. Now that's a little bit better. They don't have to be perfectly exact, but close enough. What I want to do is make a connection between the two of these models, they're not connected to each other, they're just positioned really closely to each other. So we'll go to make a connection, and the master has to be the buoy. In this case, the follower, the only follower available is the cable, and we're going to do a point connection. So is it constraining node N? No, it is not. And now we need to express this connection location in terms of the rigid body frame. I've just made a very quick model of the rigid body buoy. I've left the rigid body frame in just at the very center of everything, and this, I know the cylinder hull is 1 meter tall. Let's double check that. There's our length, yes. So it's ½ meter from the middle to the bottom. Maybe we'll give it a little bit of extra space off the bottom. So we'll go back to the connection here. If you can always go back to your connections by clicking on any D object and click on the connections, and you'll see all connections between them. We'll put this, we have the blue axis here, Z positive down. We'll put this as 0.75 meters. It's going to be a tiny bit below here. Now you won't see it update, but it's going to update once we start the simulation. Now we've already got a current going, and there'll be a little bit of transience as the connections settle themselves out. But what I want to do is we'll just start with some waves. Now I'm going to change to wave type 8 just to show some dynamics about what's happening in here. If we right click and resolve follower properties, we'll just quickly arbitrarily pick 5 meter significant wave height. We're not going to change anything else. It's got a default wave ramp of 10 seconds. There's a current ramp from the static analysis process. We'll just turn that off. And let's set this to 60 seconds, 0.1 file output rate. And let's see what we get. We'll let that run for a bit and check on how it's running. Okay, some time has passed and got a good amount of data, so I'll just pause this, open up some results in PostPDS. Go to engineering view as it moves a little bit faster. Let's look at the buoy here. So right at the start of the simulation, remember there's going to be a little bit of some transience as it just kind of settles, but it's pretty close to how it needs to be connected to the mooring. And as you can see with the waves ramping up, we have the buoy tracking the surface, and the self-stable buoy tracking the surface much more like you'd expect to see with the rigid body model. This is just a simple example. It's meant to highlight the process. You can get a lot more detailed complexity in the layout of the rigid body with different hull features and so on. But there is a little bit more involved if you want to look at a more complicated platform like this. So I hope that helps, and thanks for watching.